Here's an example of a limit that might give some of you troubles. The limit as x approaches 0 of sine inverse of x divided by x. So first off, just a few remembers. So remember what sine inverse of x means. So for this problem, we're going to have to do some sort of a substitution. So let's imagine that we said u equals sine inverse of x. What's that actually mean? Well, sine of x takes in an angle and outputs the height on the unit circle, or opposite over hypotenuse. So if you had a picture like this, sine would take in this angle and spit out this height. Sine inverse takes in the height, so the length of that line would be x, and this angle would be u. Okay? So if sine inverse of x equals u, that means sine of u equals x. Okay? Similarly, you can think about as x goes to 0, what happens to u? Well, can you see that as x goes to 0, as this opposite side goes to 0, the angle u goes to 0. So we're going to do a substitution over here, but we're going to substitute in all the pieces. Okay, so sine inverse of x is u, but we don't want to leave it with part u's and part x's. That's going to be really problematic. What's x in terms of u? Well, x is equal to sine u. And what is the limit as x approaches 0? Well, it's the limit as u approaches 0. So this is something a lot more familiar probably to many of you. Now, there may be some of you that look at this and say, but I only know this definition. Just for differentiation, let me use a different variable. The limit as t goes to 0 of sine t over t is equal to 1. I know this. I don't know what happens if you have the t on top and the sine in the denominator. Well, I would say just intuitively, if a fraction approaches 1, its reciprocal approaches 1. Okay? But there is a mathematical way to prove that also. Let's imagine that I'm trying to show what the limit as t approaches 0 of t over sine t was equal to. And we knew this fact. This is sort of the more common version to see it, but the reciprocal is also equal to 1. Well, here's what I could do. I could say, let me employ a little bit of algebra here. I'm going to, well, maybe I'll just do it in this step. I'm going to multiply by 1 over t and 1 over t. That's legal because t is near 0 but not at 0. So these denominators are not 0. Now what I have is in the numerator I have t times 1 over t, that's just 1, over sine t over t. Well, that limit as t goes to 0 is just 1, so I get 1 over, using this last fact, 1, which equals 1. Okay, so this piece here is indeed equal to 1, and I have my limit.